Okay, so I want to go over rationalizing the denominator when the denominator is a binomial. So remember, a binomial means that there's two terms in the expression. We're going to simplify 2 minus root 3 multiplied by 2 plus root 3. Okay, so we have to use FOIL because we have a binomial multiplied by a binomial. So I've got my first, which is equal to 4, outside, which is positive 2 root 3, inside, which becomes negative 2 multiplied by root 3, and my last, which becomes a negative root 3 multiplied by root 3. Alright, so I'm going to simplify this. We have 4 plus 2 root 3 minus 2 root 3, and this, hopefully we remember, is the same thing. If we look over here, we've got negative root 3 multiplied by root 3, which is the same as negative root 3 multiplied by 3, which is the same as negative root 9, which is just equal to negative 3. So this becomes negative 3. Okay, so I'm going to simplify some like terms. Notice that I have two constants. I have 4 and a negative 3, so that is going to become 1. Now, the other thing that I want to collect is, here we have root 3's. Okay, so these are like terms. I have positive 2 of them here, and I'm taking away 2 of them here, so they become 0. So I'm just left with 1. Now, what I want you to notice about this is we had a difference of squares. So the first term was the same, the second term was the same, and it is a difference of squares because one of the terms is negative. Alright, so this is going to be kind of one of our main things for when we rationalize the denominator, where the denominator is a binomial and has radicals. What I want you to notice is that my roots actually canceled out. Okay, and all I had left was, in this case, the number 1. It's not always going to be 1. It just happened to equal 1 in this case. Alright, so we're going to use this concept. So if I give you example 2 and I say simplify. So we want to simplify this. Okay, now my denominator has a root in it. Just as we discussed last class, we cannot have roots in the denominator. Okay, and so I need to find a way to get rid of the roots in the denominator. And we're going to use this idea of a difference of squares, because when I do a difference of squares, the roots will always cancel out. So my denominator, which is 2 minus root 3, the difference would be 2 plus root 3. So notice now this is a difference of squares. Whatever I multiply the bottom by, I also multiply the top by. Okay, notice that I'm multiplying the top and the bottom by the same thing. Okay, so if I just look at my top piece first, okay, I'm going to look at them separately. I have 5 multiplied by 2 plus root 3. I'm going to distribute this. So my first thing, I get 5 times 2 is 10, plus 5 multiplied by root 3. So I'm done for my top. My bottom, a little more complicated. I have 2 minus root 3 multiplied by 2 plus root 3. We actually just did this one, so it's exactly the same as the one that we did up above. I'll do it again though. So we FOIL first. We get 4 outside, 2 multiplied by root 3, inside, negative 2 multiplied by root 3, last, minus root 3 multiplied by root 3. And this simplifies to 4 plus 2 root 3 minus 2 root 3 minus 3. And we did this up above. If you're confused, just scroll back a bit and look at the justification on why this is equal to negative 3, this whole thing. Okay, so I'm going to simplify further now. Right away, I can see I've got constants. 4 minus 3 is 1. And then I also have root 3's here. I have a positive 2, and then I have negative 2 root 3's, which is 0. So my bottom becomes 1. Now, of course, I've got to piece this all together, because a fraction is top divided by the bottom. the top is just 10 plus 5 root 3 over 1. We don't need to write this, so it just becomes 10 plus 5 root 3. And that is my answer. One more example. Okay, so again, simplify. We don't like having roots in our denominators. You're going to have to be able to rationalize these. And so again, we're going to use the same process of using difference of squares. So this is really important. We're using difference of squares. Alright, so if I have a positive 2 root 5 plus 3, one of these has to be negative to become a difference of squares. And then whatever I multiply the bottom by, I also have to multiply the top by. Okay, so I'm going to do it in pieces. I'll do my top piece first. My top piece is 7 root 5 plus 1, and that whole top is multiplied by 2 root 5 minus 3. Oops. Alright, so I have to FOIL. So what I have here is if you're not sure, just write it out piece by piece. I'm doing 7 root 5 multiplied by 2 root 5. Okay, and then I'm going to do my outside minus 3 multiplied by 7 root 5. Inside plus 1 multiplied by 2 root 5. And last, I have plus 1 multiplied by negative 3. And I'm going to simplify a bit. There we go. Okay, so all that this piece is saying, it's all multiplication, right? In between these, we have multiplication happening. So I have 7 multiplied by root 5, multiplied by 2, multiplied by root 5. Okay, remember the order of this doesn't matter. Okay, so we're going to reorder this. I'm just looking at this piece right now. 7 multiplied by 2, multiplied by root 5, multiplied by root 5. Okay, and I can simplify this one more time. This is 14, and root 5 multiplied by root 5 is 5. Okay, and 14 times 5 is going to be 70. So all I've done here is I've simplified this piece. Okay, and then I'm taking away, I've got to simplify this piece, minus 21 root 5. So I'll just, next piece, I have plus 2 root 5. Actually, maybe I'll erase this piece here because we can simplify some more. So here, let's just finish this. We've got a positive 1 multiplied by negative 3 is negative 3. Here we have some like terms. Okay, they're both root 5. Okay, they're both the square root. So I've got negative 21 plus 2 of them, minus 19 root 5. And here I have minus 3. So minus 19 root 5, minus 3, minus, so it's 70 minus 19 root 5, minus 3. And I've got another like term here. So I end up with 67 minus 19 root 5. Alright, so I have my top. My top is done. Okay, it's a little bit of work. It's okay. Now I've got to do my bottom. So I have 2 root 5 plus 3 multiplied by 2 root 5 minus 3. Okay, let's FOIL. First, okay, so I have 2 root 5 multiplied by 2 root 5. Outside, I have a minus 3 multiplied by 2 root 5. Inside, I have a positive 3 multiplied by 2 root 5. Last, I have a positive 3 multiplied by a negative 3, which is just going to be negative 9. Alright, let's simplify. Okay, I hope by now, especially after the last one, you see that this is all multiplication. Okay, all multiplication here. So I can rewrite this as 4 multiplied by root 5 multiplied by root 5 minus 6 root 5 plus 6 root 5 minus 9. Root 5 multiplied by root 5, you should see simplifies to a positive 5. And then I have minus 6 root 5 plus 6 root 5. They're both square roots of 5, so they're like terms. I'm adding a 6, I'm taking away a 6. I get 0. These equal 0. And then I have minus 9. 20 minus 9 is just equal to positive 11. Okay, so this was my bottom. Okay, now we've got to finish the problem. Okay, so we've simplified the top and the bottom. And my answer happens to be, what is my top piece? There we go. Actually, maybe I'll move this over so you can see it better. Okay, so we've got 67 minus 19 root 5 over 11. There's nothing else I can simplify here. This is my answer. So these feel a little bit crazy, but if you just do the top piece slowly and the bottom piece slowly, you'll get the right answer. Make sure that you're always multiplying the top and the bottom by the difference of squares in regards to the denominator, and you'll get the answer. And that's it.